Okay, good afternoon, everyone. I hope you are doing great. The thing is, as you remember, we talked about neural nets. And today we want to cover a part which is super important. At the end of today, we are going to get to the end of chapter 1. Next week, we're going to start chapter 2. So one of the things that we repeatedly talked about, and I want to, again, not only talk, but also ask your opinion and see if you can answer my questions, is, where's the paint? Everybody, you know that this is deep neural nets, or we say convolutional neural nets, or the other name for it is CNN. Right place. The first layer is the input, and the last layer is the output. What do we call the layers in the middle, Jason? Your hidden layer. Yes, they are hidden layers, right? And imagine that this is for handwritten digits. No matter what number I'm gonna pick and show you, what number I'm gonna show the system. Guys, tell me, what could be the chance of each of these numbers to show? Sorry? What percentage could be, what is the chance of each of these numbers? What? 10%, because it is randomized, right? So the chance of saying it is 0 no matter what number it is, it's gonna be 10%, 1%, and so on and so forth. That's correct. But the thing that I want to ask you is, let me just simplify it by can you see that? We are going to have lots of neurons in the middle in these layers, and they are connected to each other. And finally, they're gonna say if it is cat or dog. You remember? This guy off. Thank you. It doesn't work. We have the first layer, which is input. We have the next layers that they are hidden layers. And finally, in the simplest way, we have what? Cat or dog. They are fully connected to the next level of neurons. And this is going to be like that, and so on and so forth. What do we call these edges that they connect neurons together? Guys, no trick question. There are something that we have gone through it several times. What do we call, sorry? Yes. These are weights. What are the values that we impose on top of each hidden layer? At the beginning, it is 0. And the reason to impose that value is just lifting it off or suppressing that column. What do we call it? Yes?
Biases?
Yes, they are biases. So we start with randomized numbers. I'm talking about the current neural nets. If somebody has read about the state of the art machine learning, deep learning, you're gonna see there are some major changes here, but we are going to use random values for weights and biases. In that case, I'm gonna show the picture of cat. Computer might say it is dog or correct. Question, imagine that you have 10,000 pictures. Guys, next week we are gonna start chapter 2, working on hands-on. If you get today's session and what we are talking about, then you're gonna have easy job. There are not gonna be more than 20 lines. Natty, there are just 20 lines of code. Not tough. But the difficult part is this one. Okay, I'm gonna show you this picture. What is that picture? Randomly you say cat. Listen, the good thing is we have a data set, and that data set contains 10,000. Okay, guys, this is super important. I told you, if you think that you are going to distract yourself, please just do something immediately to get back to class. Okay. We have 10,000 pictures, images, and those 10,000 images, there's a good news for it. They have something that we call them label. So we have cheat sheet already. If it is cat, dog, cat, and so on and so forth. What is this part? They are our inputs. X's, x1, x2, x3. For this, for example, if it is 28 by 28, 784 x's. Is it clear so far? What do we call these guys that we already have? Ground truth, output, Y, all of them are correct. Label, but what is the thing that you are gonna predict? Can anybody tell me? Sorry. No, what is the thing? What do we call the thing that you predict? Y is the actual label. What is your prediction? Okay. Next week, we are gonna have quiz from page 1 all the way to end of the page 25. Read it. I see that it's like you just woke up and just came to the class. Not really. These are simple questions, guys. So we have Y, and what is this one? Y prime. What you predict is Y prime, what the actual label is Y. So are you going to fix the network by saying the first mistake? Are you going to do that? So to use this. Thank you very much. Question, are you going to fix based on the first picture? It is cat, you said dog. Are you going to fix the network based on that? If you say yes, it's going to be very much cumbersome for the system. What about this? I'm going to calculate the differences between Y and Y prime. Y prime. So we call it delta, the difference, right? If you do it for one picture at a time, it's going to be very much cumbersome. If you wait all the way to the end, it's not going to be accurate as well. So two sides of extreme. If you do it for every single picture, if you wait and calculate delta 1, delta 2, all the way to delta 1, 10,000, and calculate the average of all of them. What's going to happen? Too late to do any modification. Very rough, right? Is there any kind of middle ground between these two? This is something that you are going to see in the code. They call it batch, the batch size. And most of the time it is something like 128, 256, 512, and so on and so on. Huh? Means what? Means picture 1, picture 2, picture 3, all the way to picture 128, calculates delta 1, delta 2, all the way to delta 128, and then decide the average. And then based on that, you got the prediction, right? You got the average of delta. What are you gonna do? What is this? Sorry, what is this value that we have? We call it what? That's delta that we calculate from a batch. What do we call it? Loss score. That's the loss score, right? Who is responsible to calculate loss score for us? Next, thank you very much. At least we have one person who experienced loss function. Guys, for the quiz, you need this specific one. So loss function is what calculates, what is the other name for loss? Okay, sir, there are two other names that people use for loss function. At least you can answer one of the questions correctly. What are the names for loss function? Words you have to search, deep learning, loss function, yes, same. Cost function. Cost function, lovely, cost function. What else? Objective function. So let's just consider 2 bonus marks for Nash so far. 1 for Mr. Kumar. Taban. What was your number? Lovely. And 1 for okay. So now you calculate that loss. What is the next responsibility? What should you do when you calculate loss? Well, loss is the distance, but what should you do after you know that that's the distance between what you should, calculate and what is the actual truth? Okay, suggestion. This is what we covered yesterday. This is the picture. Page 9. Please quickly go to the graphs 9, 10, max 11. See what are the things that we learned from it. Nine, in terms of the number that we can see on top of the page, 34. PDF wise. Yeah. So now,
Got to take loss square, and then you put it into optimizer.
okay, awesome. So look at this one. When we get the prediction, we need to calculate the distance between y predict and the actual truth. It says true target. We call them targets, label, ground truth. There are lots of names for this. Y simply. The distance between these two is calculated by using loss function, objective function, or cost function, which provides for us a number, which we call it loss score. Again, loss score is the average for the whole, or for just one, or for a batch. Yes, William? Tell me. We actually calculate for one, but the action that you're going to start doing is after one batch. You're not going to change it for every single one. That's going to take forever if you want to do it that way. Does that make sense? Okay, this is a question that it has 3 bonus marks, means 0.75, just this question. I'm going to ask you, use ChatGPT, use anything, and see if you can find the answer. First thing first, I'm going to get to that. Some people could just get part of the answer, and that was very much valuable. We calculate that delta loss, and from that moment, we do something, as one of the friends just addressed. The name is backpropagation. Backpropagation is a mechanism that we use, but who is responsible for backpropagation? Like, loss is a value, is a score. Who is responsible to calculate that? Loss function. Who is responsible to use backpropagation to fix the error? Anyone? Okay, Google this. This is a simple question. Who is responsible to use loss function to optimize the values of weights and biases?
Is it the network we're trying to train?
Pardon?
The network we're trying to train?
But there's just one. Yes.
The framework, collaborative.
Look at this picture. This image says that we have that loss function and it calculates the loss score. The next one tells you something. Just read this paragraph and give me the answer, please. I'll just read it. Read what it says, and then just give me the answer, please.
Are you asking who would use this loss function?
Who does it and what they use? Yes, William?
Yeah,
Yes, exactly. Optimizer is the one who takes the value, the loss score, and does the changes to optimize weights and biases to correct. And the mechanism that optimizer uses to change those values is what? Backpropagation. So backpropagation is like changing, guys, from which side to which side? From right to left or from left to right? What is the role of backpropagation? Changing the values, right? Optimizer uses backpropagation mechanism to change the values. Is it going to happen from output towards input or from input towards output? Sorry?
Output towards.
Yes?
Essentially, the output to update the data.
Pardon me?
Like, essentially, does it, the process of the backpropagation, it use the output to update the weight of the input?
I'm gonna show you something. All of you have seen such things, right? It's exactly like shaking the ropes. That's going to fix error. Guys, those weights and biases, they are linked to each other. There's one thing before I proceed. Maybe the blame is on me that I give not that much hard quizzes or exams. And that is not motivating you to study. Before I go very much further, before I explain this, I want to tell you one thing, guys. Based on the statistics, they recently said more than 40% of the jobs are going to vanish pretty soon because of AI. Whether you want it or not, many things are going to change. Many things. I don't have any much emphasis to tell you come on time or be prepared for the class because that's your part. And there's the only thing that I can say is, guys, pretty soon you're not going to have somebody like me, hopefully, in education. You're going to learn differently. We already have started that journey. I can't tell you those who are in the middle of AI are those who are going to survive the situation. Whether you want it or not, many already we have seen. For instance, previously, we needed to give our documents to people who are expert in editing. Now, are you doing the same thing? Have you ever seen anybody who said that? Do you know someone who can fix my grammar? Thanks to ChatGPT, Google Translate, Grammarly, tons of other things. You see that people who are expert in editing, they have technically no job. And the list goes on. Many things are going to change pretty soon. I have seen just a few people that before they come to the class, they read the chapter. And when I start telling, they grab everything. Guys, unfortunately, that's a fact that 10-20% of people, what I'm telling you, I asked many people, many profs here and there. I participated, can you believe it or not? I go and participate in basic classes to see how they teach these concepts. And if I wait there, I waste my time, 4 hours that I told my friend that five minutes out of that 4 hours could just gain anything. But that 5 minutes is fine for me to stay there and bring the knowledge that they provide for the students here. That's what I do. I don't expect everybody does that, but if you want to get the best out of these classes, not a bad idea. Read it before coming to the class. Guys, it's like 3 times that I just said, what do we call this? And still some people say, what do we call it? Edges? Instead of saying weights. Anyway, getting to that part, we have values over here. We shape those values, change them. That is why they call it back propagation, because it goes from output towards input. It is back propagation. and they change, they tweak those weights and biases. Huh? Doesn't make sense? And you are gonna get at the beginning, imagine that the accuracy of the system is something like 30%. Awful. Next round after, guys, when I say 30%, is it for the first picture or for the first batch of pictures? Lovely, batch of pictures. Because we calculate that. And are we gonna do anything immediately after the first picture? No, Jacqueline, we're gonna do it after 128 pictures. We wait, we get 128 pictures and then calculate the average, and then we start changing a little bit. And do you think that after 30%, we are gonna get next round 90%? No, it's gonna be 32%. For the next batch, it's gonna be 35, if you're lucky, and so on. All the way, when you get to the last batch among 10,000, you're gonna meet something like 92%, right? Forget whatever I said, now I have an important question for you. You remember that we said machine learning, deep learning are not important. Unless that you can use them, utilize them for unseen data. What is the point? You have the Y label on the right side. What is the point if you just see this and check the label that says it is cat, it is dog? There's no point for that. The point to start when you can just bring unseen picture and the computer can predict that, this is cat or dog, right? To just have that, this is another thing that we talked, but I want to see if everything, you remember everything that we said. Okay, we check the first picture, we check the second picture, we go all the way to 10,000 pictures. What do we call this? Checking all 10,000 pictures. What do we call this?
Training.
Pardon me?
Training loop.
What is that training loop? What do we call it? There's a specific name for it. Learning is, guys, I quickly give answer to all of the things that we said. Learning is nothing but fixing those weights and biases. Learning is that. Again, checking 10,000 pictures, all the pictures, we go from picture number 1 all the way to 10,000. What do we call that? No, epoch. That round is called epoch. Next, we go 10,000, we check 10,000 pictures, 1 round. Then it's going to show after that 72%. Next round, it's gonna show 84%. We do all the steps, 10,000 pictures, we go through them all. This time, the average would be 84. We keep going. Do you know the normal number of epochs that we use? How many epochs we use normally? Just Google. How many epochs we use normally in deep learning? Yes.
On the textbook, it says typically tens of iterations or
Love.
thousands of examples.
Exactly. We use mostly numbers between 10 to 30. Right? And guess what? With the current algorithms that we have, it goes all the way to after 30 times. Nash, do you think it's going to be around 80 or something? It gets to almost 100%. Can you imagine? 100% accuracy. Now, the question that I have for you, you have a model that has 100% accuracy. Do you think that 100% is valid? Yes or no? Is it valuable?
100% off of unseen data or?
No, it's on the data in hand.
Well, means like, if it's doing it with unseen data, it is valuable, yeah.
No, it is. It is the number that you achieve based on the data set that you have seen. This is, sorry,
Like, that's it, with unseen data that.
that's lovely. I want to get there. This is what I ask. Guys, please ask your friends in a group of 2, 3, talk about this. You train your model with the data in hand, and the accuracy that it shows, it's 100. 100% means no flaw, no gap, no mistake. All the pictures are categorized correctly. Now it's the time that you need to talk and see, is it valuable? Yes or no? And is it too good to be true to have 100% accuracy in a model? If yes, why? Oh.
That's one. Oh, okay. Okay. Yeah. Wasn't sure.
Just to make sure, people at home, you can hear everything and everything is clear so far? Prakash? Okay, thank you. Okay, technically, if you have 100% accuracy for the data in hand, You just made a kind of Excel file, a lookup table. Is it the aim of what we are doing? Did we want to have a lookup table? Ask the question. No, definitely not. Listen to this, please. Imagine that I increase the number of hidden layers. Guys, can you just be with me? And 1 second, if you're not following, you're not gonna grasp the idea. Imagine that we have hundreds of layers, and I show one picture, and that picture is going to change these neurons' values or activation we call. Imagine that those neurons are nothing but just, I'm simplifying, guys, intentionally I'm simplifying. They are just bunch of zeros and ones. Does that make sense? We have lots of layers, lots of neurons, and they are gonna be just bunch of zeros and ones that bring us to correct answer. Where is the dog and cat? This one is going to say this is for this picture is going to be this and cat. This picture is going to be this and dog and so on and so forth. Technically, for any picture that you show, there would be a unique code for that picture only. I repeat it. Technically, if you have lots of hidden layers, lots of neurons, you have a specific code for every picture. Imagine that we have a person who has amazing memory, look at anyone and say that, I know that person, the name is this. I know that person, the name is this. We memorized it. Is this what we are looking for? No. We want to see unseen picture and say, the feature shows this is cat. We shouldn't reserve any code for that specific. You know what I'm saying, Julian? We shouldn't have 0011. It's like a code for one picture. We should avoid that. And if you get 100% accuracy for the pictures that you have in hand, then go and test it. You're going to see, that's going to be 70% for unseen data. Awful results. And what is the reason of that awful result? You memorized it. You did something that was too good to be true. What do we call too good to be true in machine learning, deep learning? Yes.
Is it over 50?
Do you remember that I asked you please bring something to take notes? These are the things. Write that one sentence. When it is too good to be true, you have overfitting. We have overfitting. We experience overfitting when the result is too good to be true. Done? Okay, what should we do? Now, I have this question for you. We said, I'm going to just give some simple answers, but I don't think these are the things that could work. We have 100% data. We divide it into two portions, one 80% Jacqueline, and the other 20% is for what? I forgot the name. This is for training. This is for loveliness. This is training, and this is testing. The problem is you go through the epochs. This is a valid question that I received. Let me just explain to everybody once again. We have 10,000 pictures. If you go from picture 1 all the way to picture 10,000 and you show them all to the system, it is one round, one epoch, right? And after every 128, for example, after every 256, you say, okay, wait, let me just use back propagation to fix all those weights and biases. and make it better and better. You're following the story that's happening behind the scene, right? Awesome. And then you do it 30 times, 30 rounds, 30 epochs, 30 10,000, not 30 pictures, 30 10,000. And then you have 100% accuracy. But when you test the model that you have created, it's going to give you 70%. That 100 minus 70%, 30% is the overfitting amount. If it is 85 and 82, this 3% is overfitting amount. Still, but acceptable. You can say, I can live with this 3%, not that bad. Mostly when the overfitting amount is something like 1 to 3%, you can live with that. But more than that, it's not something that you're expecting in your model. So, okay, solution. I'm going to leave this one after 2 epochs. And then I'm gonna check and I'm gonna see after 2 epochs, I got 84 here. With the testing data, actually I got 87. Which one is better? With the testing data, it shows better performance, right? In that case, it shows that you couldn't get the best performance of the testing part, training part. Means you are underfitting. Underfitting means you have room to progress. Does that make sense? Overfitting means that too good to be true. Underfitting means that, hey, don't give up. You have room to progress. But my problem that I couldn't solve is this question, which has 3 bonus marks. Oh, this one has 2. The next question is 3 bonus marks. Guys, what is your solution that I can fix this problem? Because you might say, Reza, do it 10 times. When I do it 10 times, then it is 92, 87, 5% overfitting. When I do it too little, underfitting. So what can I do? You can think, you can search. And please, because I want more people to have a chance to get bonus marks for these 2 bonus mark question. Whenever you are done, give me a signal. I'm going to check on your computer. And then, yes, coming to it. Exactly. What could be the best? Okay. Imagine that we don't have that possibility. This is chapter number 4.5. That we have techniques like the quality condition. We are gonna just increase the size artificially, but it's not what we. Sorry. I imagine that the data set size is something that we have in the solution, but it's fixed. Right? In that case, we need to define another solution. But good. Same, right? Yeah. Thank you. This is the yeah. That's great. So that's what I want to about data implementation is once we run that, like, but I can only imagine that the data sets that we have, we can have the something express, then what we can do. You have one, but yeah. Let's think about other solution. That's awesome. That's another, but that is gonna happen during chapter 3. Okay, so you're going way ahead of chapter 2. Great. Let me just give volume one, bonus marks. How many bonus marks do you list in the previous week? I can't imagine whenever you start and eventually you get instruments. Keep doing. Well, augmentation depends on the things that you're gonna see at next time.
Like all learning. And to work.
Regulation, that's as I know. I'm happy that I see the new persons. Final way. Hey, yeah, that would be great if you can, another study. Yes, I saw a hand up here. Do you want? Yeah, sorry. Thanks. Okay, that's the point. I'm gonna explain that.
And then for underfitting, reduce the costs. And increase the duration.
Lovely. Excellent, guys, most of you got this answer correctly. Let me just. Many of you said, hey, if you want to tackle the underfitting problem, you need to increase the number of epochs. Absolutely. The other thing that you can do is to increase the number of neurons in each hidden layer. 100%. The other thing that you can do is to increase the number of layers. That's absolutely correct. But we should be very much careful when you want to add the number of neurons, because it's like this to just jump to the overfitting. You're going to see some graphs around page 100 something. I'm not exactly sure. It shows that it's just going to go crazy when we increase the number from 64 to something like 512. The overfitting happens suddenly after the first iteration, first epoch. But my question, the other thing that you said was, Reza, if you have a data set, if you use more samples, then it's going to help you to tackle the overfitting problem. More samples, more patterns that you can learn. Right? I'm happy that most of you are paying attention, because these things are gonna stay. Listen to this. I heard here and there from you that you can use augmentation, right? But what does it mean? Whenever your data set doesn't have enough number of pictures, for example, and you want to classify cat or dog, what is the role of data sets? To just train your model as much as it can. If you see any cat in any condition, you can recognize that, that's a cat, right? So for augmentation, what happens is you're gonna zoom in to have a cat that doesn't have ears, for example. To zoom out, which is smaller cats, to tilt the head, you just tilt, do all those things to that poor cat's picture to make 10 pictures of the same cat. Then instead of, for instance, 200, you're gonna have 2,000 samples. Does that make sense? You're absolutely right, but let me get back to this question. I said we have training 80%, testing 20%, and the problem is I don't know where to start. You told me that in general, Reza, in general, if you want to tackle the underfitting, increase the number of neurons, number of layers. Accepted. If you face limited number of examples, your model is very much biased towards the data in hand. Increase the number of samples, correct. But I'm talking about, imagine that you don't want and you are not able to increase the data set, you don't want to change anything else. Where is the place that you can say, hey, I'm done, I'm not gonna go any further? Now you are ready for the next part, which is super important. Guys, don't worry, I'm gonna just knock the door. This is the important part. What do we have in hand? Training. You might say, Reza, without anybody's awareness, bring a little bit of testing and use it there. This is cheating. We never do that. Test should be a surprise data. We should test. The name is suggesting by itself. You shouldn't train. But you can do one thing with the train part. Instead of using the whole 80%, you're gonna say, let's use 60% for training, 20% for validating what we are doing, and 20% at the end for testing. Does that make sense? What is the meaning of validation? And one person said cross-validation. But cross-validation is one of the validation formats, validation in general. Look at this. You are going to train. When are you going to tweak your weights and biases? After each batch of data, right? When you are done with the first round, at the end, you created your model already. Then you are going to use validation. Can I have your attention? Look. It's going to work like this. It's going to be 74% first round for what? For training. But this number for the validation would be something like 82. Huge gap between validation and training. First round. Second round, this guy is going to jump to, surprisingly, it's going to jump to a number like 82 or 82.5. And then this guy is going to just be 84. Still, we have room to progress. Do you see that? Still, we have room to progress. What could be the next one? 3. This time, the guy is going to do what? 85, for example. And this one is going to be 84.5. Tell me, are we going to continue? Yes or no? This is, if I want to ask someone this question, that almost, well, we had 2 groups of people, those who were not sure and they didn't participate. Some people said no, right? This is a kind of interview question that I'm gonna say, are we going to continue? And people who say no, hey, you have progress here. It's getting better. You're gonna stop it for the next round. Imagine that you're going to have 89% here, but it's going to get worse. 82. If up 1, 2, 3, 4, guys, where should you stop? Tell me. If up number 3. When you start deteriorating, decreasing, sorry, the percentage, you're gonna get worse, right? Guys, yes, we are going to have overfitting, but we are gonna keep moving because the system is going to face progress. There is no room after this to get better. After that, you're wasting your time and resources of the computer. You're going to memorizing if you keep doing. And that is why after a while, you're gonna see here, you will see 100%, while this guy is something like 62. Awful. It memorizes all the pictures, but cannot do any job, acceptable job with unseen data. Whatever you learn, especially about this part, especially about the part that you said that, okay, Reza, when we pass this threshold, yes, you have overfitting, but that overfitting is minimal. It's just 0.5%. Still, you can keep going. But after this, you're not gonna do it. When it's going to, just get worse. Please, whatever you learn from it, write it and share with your friends. Overfitting happens. Yes, we have overfitting here, but we keep going because still we have problems. Right? We stop it when we have still progress regress. We just make it worse. What is the specific word that makes worse?
You can say regressing.
Regressive is fine. Which one is the next? Regress or wait?
Regressing, moving backwards.
Oh, awesome. Thank you. I'm sorry, I cannot hear you.
Can you explain it once again? I'm a big fan.
Sure, I will. Okay, now this example, I guess we have more numbers. We can feel the things better. Let me just say we have epoch here. And what is this epoch? Epoch number 1, 2, 3, 4, 5, and 6, 7. Okay. Can I have your attention? The first round, it is very dismal, right, Malik? The first round, it is very dismal. The result is not that much promising, 72%, while validation shows something like 81%. Guys, this situation, is it overfitting or underfitting? Underfitting, you have room to progress. Is it clear? Okay. How about this one? Next round, next epoch, epoch number 2, you're gonna get I'm gonna send that to group as well. In the next round, you see that the accuracy is 82% and validation is 83, still underfitting. Next round, still we have underfitting, but it is tiny, teeny. Next round, we have overfitting. It is 87, while here we have 85. Does it make sense? But should we stop here saying that, okay, because we have overfitting, let's stop it? No, our model is going to get better, right? We go another round, and that in that round, you have a little bit adjustment, a little bit progress, which is 85.1. But the overfitting is huge in here. Guys, where should we stop if I give you this as a test in your quiz or in your exam? Especially now we know that some people, they might choose 4, and we know the reasons. What is your choice? Okay, look at, imagine that Reza has chosen 6. Okay, in this round number 6, the result that we get is 84. Why 84 point something? While in number 5 we had 85. It was better. So we went to 1 round more. We already have huge overfitting. At the same time, we didn't get any general improvement. Does that make sense? So the best is, as James said, is round number 5. Everybody, yes? True. The overfitting tells us what is happening. Your model now, it's very much good with data in hand, but it doesn't good amazing with general data, with unseen data. Okay, now the actual question. Can you please think about this? Why in many scenarios I can tell you always, and this is the one that I told you, if you followed everything, now you could be able to answer this 3 bonus mark question. Guys, most of the time we have this tendency. The training data would be, for instance, 65, while the validation starts with something like 80. Or in another one, the training data is going to be 74, the validation data would be 82. You see the difference? Why always? Why always? The result in training data, first epoch, first round, is way lower than the validation. The at class code for this class is C1RU. Yes, sir. That's absolutely right. That's what it was. I want to understand the. Yes,
If you have like the data sets.
we use the same data set, so that couldn't be the problem. Yes,
We find the threshold of the limit where it's overfitting.
good. It shows guys you're on the right track. Nice, but think about it. That's a bit. Good. All the answers are very wise. But I repeat my question, why, especially why the first epoch is way lower than the validation? Yes.
Does it handle like, the initial weights of were randomized? It's so fun, maybe like, the first pass through.
This answer deserved to have 1 out of 3 bonus marks that I promised, but still. Yeah. So anybody, and still people who can just give the correct answer, they're gonna get pure 3 bonus marks, so don't worry. I'm 100% positive when I start saying your lesson. I said, come on, it was that easy. And guess what? I taught 2 years and after that I realized this. So that is why I said that, okay, deserve to. Yes, William?
Adding on to what I said.
Okay, please. Can you, because you said it to me, can you please say to the whole class?
I thought it hadn't learned enough from the.
It hadn't learned enough. In which part you're talking about, training or validation?
The first epoch, we didn't have enough, from the training data set. Now I found the additional stuff you asked for. I think that, the initial weights.
You exactly reached to the point that Nash said, good job. Yeah, the same, still 1 bonus mark from the other alley. You just get to the same destination so far, but last chance. Who else? Listen to this. Can I have your attention, please? Okay. I'm going to show you the first picture. Is it cat or dog? Then are we going to announce that, okay, this is our accuracy? Guys, when you show the first picture, first round, first picture, are you gonna say, okay, the delta was this? Or you are gonna just say, okay, show me the next one, the next one, the next one, 128. Then that was the average of 128, for example, or whatever the batch size is. You're going to calculate the first delta and say it shows that we have 37 accuracy. Now is the time, hey, backpropagation, your task is to lower down this. Can you do that? Yes, I'm on it. So I'm gonna just work on it. In the next batch, it's gonna get a little bit better. That 37 is going to be like 39, maybe, not that bad. So the delta for the next round is like that. For the next one, it's gonna be 39.5 maybe. Then 40, and so on. At the end, we are gonna have something like 92. Can you imagine? The first time. But the average is 74. Is it clear? The average of training for the first epoch, 10,000, would be 74. Now you have a decent set of weights and biases already worked on them. And you use validation in this already prepared model. It should be close to the final result that you have. You know what I'm saying? You have changed all the things and you have this in this training. the first epoch is gonna be the average of 128, 128, 128, all the way to the end. Because we started with very low values, random, as Nash said, as William said, we started very low precisions, then it is increased. But when we get to the end, here we have already decent number of weights and biases already tweaked, altered. A predefined, a decent weights and biases give us this precision, this accuracy, sorry. And the next round, why we have always a jump? We are going to have something like 80 next round, and this one is going to be 82, because it's not going to start from something random. It just improves already weights and biases. Guys, now can you feel what is happening in neural nets? If you can feel what is happening, coding is the least thing that you have to worry about. If you can just visualize what is happening in every step. And now we can see, okay, validation help us. And that is why if you take care of validation most of the time, the difference between validation and the test results would be something like 0.5. Most of the time, they're pretty close. Either a little bit overfitting or a little bit underfitting. And this number is what we. But there's one thing. This is something that I want to tell you. Validation. Are we going to use validation to build our model or to validate our model? The answer is clear. I intentionally used, I didn't say that to test our model. Are we going to use validation to train our model or to validate? So we are not going to engage them into training. But what if I start changing the number of layers? Validation got increased. I changed the number of neurons in each layer, then the validation gets a little bit better. Are you following? In that case, indirectly, you are giving a cheat sheet to the training. So if you want to tweak, you shouldn't overdo that process. You should keep it limited. If you keep altering your model based on the feedback that you get from validation, it's cheating. It's going to work kind of fine with your data in hand, indirectly with unseen data in validation, but not necessarily with unseen data. By saying that, now it is 117. I think that we have a nice, clear understanding of this. We can just go to the theory part, continue the journey using the book. Let's have 10-minute break. Let's get back at 128. Thank you very much. Where is it?
Yeah.
See you later, man.
Maybe like two and a couple of things. I don't like, it's like, that's me. Yeah, I was my second, like, I'm someone. So we're kind of like waiting for us. Waited.
Okay. As we stated, we have started this page. We talked about different names for loss function. You remember we said that objective function, also cost function. The old book is not very much accurate in these pictures. Look at the optimizer that we have. It shows that it changes all the weights. It doesn't show, I think that the next version of the book should show that it is going to change the biases as well. if you forget the term epoch, you see that here it mentioned the epoch. Some of the things that we see is happening here. I always suggest my friends, whether you want it or not, things are going to change. If we think that, hey, I designed a database and everything is fine, so I'm going to work in future as database designer, or as people who are in web developing, think twice. I want you to read the list. We are in page number 10 and 11. Okay. Read these things. It says that image classification. The next is near human level speech transcription. Actually, I think that now it works even better than human. I was in a clubhouse and somebody was talking and background noise was a traffic and I barely could hear anything. And the transcription was pretty neat and nice. It shows that it could get rid of the noise and just use the actual voice of the speaker. We passed that era. It's not that much interesting. Handwriting transcription. And using those assistant like Amazon Alexa. My question for you is, think about it and see what could be the potentials and possibilities that we are going to have in near future. I'm not talking about 100 years from now. 5 years from now, where do you think we are? Are we going to code inside a company using C#? Do you think that we are going to work as web developer anywhere? So what are we going to do? Managing systems. Do you think that managing systems, what do you mean by managing systems? Before, for instance, when they wanted to define a schedule, it took forever. There were few people, and after all those attempts, we had some conflicts in the schedules. A prof had 2 classes in 1 hour. There was no lab and so on. Now you give the free rooms, what you need for that specific course, and the availabilities of the prof, and done. It's going to provide you the full schedule for the whole college, 100 some just in computer engineering. So you see that now even management is something that the cumbersome part of it is done by computer, AI. What else? What are the things that we could use AI, but we don't see it? And why? And I have points to ask you these questions. It was 3-4 years ago, there was one prof at George Brown. Now he's a full prof in University of Fraser Valley. He told me that we went to one of the PAC meetings with one of the companies. They were like Tridal. I've forgotten the name of that specific company. They are like Tridal builds for people, residential buildings, while that one for governmental organizations, so huge kind of mass builders. They said if you have 10,000 people in IoT smart city concept, they can hire them. We don't have anyone. I'm talking about 4 or 5 years ago. So the problem is we have some new branches of the engineering, like joint fields. We are not trained for them. That's one problem. So I want you to think about the potentials that we are going to have in 5 years from now. Let's consider bonus mark for the best answer. It doesn't need any technical skill. Just read this and think what are missing in the list. Yes, sir? I'm sorry, your voice is way lower than the friends outside the class. Medical research, right on. Can you explain more?
That vast amount of data and analysis. AI module could easily speed up. I think there was recently a breakthrough in terms of diabetes research. So patients that they made a certain drug and I think the yearly forecast for diabetic patients and mortality reduced based on drug Ozempic and similar. And that was all thanks to AI and ability to process vast amounts of data. One aspect. Also, I think cloud technology is also going to take off that because we move away from traditional hardware and on-prem. That's companies are slowly moving away from on-premise hardware and using resources in the cloud to speed up productivity and easily,
Excellent. And just to continue what Malik said, the already received. Recently, I read an article that said one of the problems that we mostly face is diagnosing cancer not in the early stage. So thanks to AI, we can diagnose it in the earlier stage, and it's very curable. It's like catching a cold, as simple as that. I'm not saying that it is not exaggerated, but we are not gonna afraid of the word cancer. And the other thing that I very much like, that was why I saw it, because the guy was an immigrant Persian in the United States. He's working on this project to make a chat GPT to talk to Jen. Can you imagine? To design a proper vaccine and to just target and attack the cancer cells, not to attack any others. One of the side effects that we have is, for instance, when they want to treat cancer, and if that person has any cancer, because they can easily lose their voice because they destroy the healthy cells as well. I was like, wow, where we are at the moment. And it's not things that could happen 100 years from now. They said that the project is going to be available for everybody in 5-6 years. I was like, wow. Right. And why we don't have it, guys, can you please tell what are the 3 stages, 3 phases that any medical doctor goes through to cure the problem, the disease? What are the 3 stages that we have? Research. First, you're going to test, right? the medical exams that we have. It could be the heartbeat, blood pressure, fever, everything. Don't you think that systems that we have already, the sensors and so on, we can collect all the data? I'm not saying that they are as accurate. For instance, the heartbeat that your watch could just collect is the same as those kind of heavy things that people attach to themselves to. But we have that up to a certain level. What is the next level? Exactly, diagnosing. And do you think that a doctor can remember hundreds or thousands or millions of samples? Is it possible? Is it possible a doctor? Yeah. And what is the next step? Based on the diagnosing, you're gonna simple treatments, right? And that is something that technology is way behind of the approach of people. Haven't you seen people that said, I saw that, I Googled it and I saw that it is this. So technically, without saying it, we have generations of doctor people. You don't know it, you just, just search it and you find the prescription. The only thing that keep that business, I'm sorry to call it that way, to keep that business alive is not being able to touch all the medicine available, right? And now, I don't want to go any further, but pharmaceutical companies are the big guys. Hey, come on, you scratch my back, I'm gonna scratch your back. You're a doctor, I know you're gonna write prescription on that. That is why we don't see AI the way that it should be at the moment for the health of people. And that's a sad story that they make money out of the way that if we are not feeling well. So we should work in a way that we are not that much ill that not be able to service the system, and we should be once in a while sick that the vicious circle just goes on. Anyway, I'm very much sure you guys, you're gonna change this. Whether you think that, hey, I'm gonna do that or not, yes, you are gonna do that. You're gonna be a part of the team. They're gonna go to an interview and they say, you know what, the research that we have is about medical things, and we are going to do this to help the people be healthier. Are you in? And then you're gonna remember this day, this moment that I said, you are gonna be pretty soon part of this. Yes, sir. Noted.
Kind of add into that a responsibility of if things and making us better prepared for like viral outbreaks,
Being prepared for?
like viral outbreaks.
Can you explain more? Can you explain more, please? Uh-huh. Okay, just even before getting to any, so we are gonna be more resilient. Uh-huh.
Like how we had other outbreaks in the past, like
True.
and like with proof on being better prepared, that maybe AI make it like 100 times more efficient.
I like that. You have heard that they could read some unknown scripts using AI. Some handwritten scripts belong to ancient Egypt using AI. Have you heard that? Isn't it strange that with AI, and that is something that we discussed, and I said I'm going to touch that concept. We thought before we need human brain to discover, decode such things, such scripts. And I'm looking forward AI to discover all the data sets about history and bring out the truth of what happened in past. We are not far from that. And I'd like to see many people's face. Guys, the real redemption is in science, and we are gonna see that. No question. You are in the right path. Just trust where you are. And I think that our responsibility is just be more knowledgeable every day. Because if you know more, you can help people to know more. This is something that the question for you would be how old this video is. And this is funny just to have a little bit of change.
Impacting the whole company?
Hi, I'm looking for a haircut for a client. I'm looking for something on May 3rd.
It turns out a big part of getting things done is making a phone call. We think AI can help with this problem. Let's say you want to ask Google to make you a haircut appointment on Tuesday between 10 and noon. What happens is the Google Assistant makes the call seamlessly in the background for you. So what you're going to hear is the Google Assistant actually calling a real salon to schedule the appointment for you. Let's listen.
Hello, how can I help you? Hi, I'm calling to look for a haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, which time are you looking for about? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like, what service is she looking for? Just a woman's haircut for now? Okay, we have it 10 o'clock. 10 a.m. is fine. Okay, what's your first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks, great. Have a great day. Bye.
And guys, you know how old this was? 4 or 5 years. What do you remember when somebody says hi hi? Nobody uses Virgin Mobile? Okay. So I'm your virtual assistant. How can I help you? What's this one? No one use RBC virtual assistant phone banking. Okay, let's just tell you the point. I actually traced that. I was like 2 years old, this system. The guy who said that, how can I help you? In 2 years, I see the progress. It's kind of like self-training and self-development. They just trained based on the things that they gathered for it in 2 years. And the more time passes, we see all of these kind of jobs helping people are going to be replaced by robots. I'm not in a place to start crying that, okay, poor people who just had that job. It's like crying for people who lost their horses or the skill that they had for horse riding when it was 1910 to 1920. The thing is, we are in the core of sector that we can predict what's going to happen next. If anyone is capable of doing that, those people are you guys in this field. So one thing that happened, I just compare myself with the previous generations. I remember that they were just relaxed after getting to university, getting the degree. Then they were Mr. Engineer, Miss Doctor. They had their title and done. And I'm telling you, my life is not easy at all whatsoever. Every day I study. And I need to study. I'm not saying that I don't enjoy it. I very much enjoy what I'm doing. But just to let you know, if I want to be in the business, I need to update myself and I told you, at the moment, I'm auditing 2 courses. One of them is very basic. And I think that for me, what is the reason to be in a class 4 hours? I was telling my friend, said that I spent 4 hours and the output from is like 5 minutes. But if I can just bring that 5 minutes to my student, that's really worth it. So I want to see what they do to teach machine learning courses. What are the things that they touch? And especially if I know that the prof is a person in the industry, definitely I try my best to get myself into their class. Longest story short, guys, let's just make the habit of learning our everyday residual, something that we do every day. The next thing that I just said, this guy, please hide. Show them. Finally. Okay. The question that it already said, and you were kind to tell, is there any final things that you want to add to this list? It says that there are lots of things that are not in the advanced stage, like using in medical and many other places. Do you have any other examples apart from the examples that our friends mentioned for AI and its usage? It said that it's not like part of our life, but it will be like internet. Can you imagine a day that you wake up and no internet signal? That happened 2 years ago, if you remember. Rogers. We didn't have good time at all. So what if one day you wake up and see that ChatGPT doesn't work, especially if you have lots of assignments? So look, joking aside, we are gonna get to that day pretty soon that you can't make decisions without having the AI's assistance. It says that believable dialogue system, intentionally I highlight that. And now you can see, yes, we have believable dialogue with computer. And it says that the risk with high expectations, we had 2 winter already. They call it, the term has come from the Cold War between USSR and United States. So we experienced 2 winter in technology, in AI. One of them happened right after symbolic AI in 1970s, and the other one happened in the era of expert systems. You remember we had that question, you said it was because of the maintenance cost, because it was not flexible, it could just answer the questions that we had, sort of the answer among the database. But the question that I have for you, do you think that the next winter is going to happen in machine learning, deep learning? What do you think? Guys, if I just turn the page, because this is the thing that we talked already. Do you think that AI is going to be the next or what? Mohammed Bilal, what do you think? Do you think that's the next winter that we are gonna, because we have hype, you remember that we just saw the hype. And if you check, please just check hype brand. I'm sorry, hype, I've forgotten the name of the hype technology. Just say machine learning. It's going to show you something belongs to 2022. And there is a company that works specifically just on this. Let me just show you the images. Yeah. Gartner, my bad. So if you see this chart, it shows that in machine learning evolution, deep learning is in here. And it says 2018, we have more recent 2022 and so on. I spent 2 minutes, check, this is the company, use this name, Gartner, Hype, Deep Learning, Machine Learning. What do you think? What's gonna happen next? Yes, William. Sorry, which one? So 2022 and hype for AI. Okay. That's it. So mm-hmm.
Say that, like, go down a bit.
Uh-huh.
Legend.
Okay.
President. Yeah. Most likely that in 2 years, we'll be plateau for the. Plateau as in like. Big amount,
Mega, sorry.
a big amount.
Okay, can you please just if you feel comfortable to just come here and explain to everybody what you got, because I can't very much.
So. From what I think, of what I see in the chart. From deep learning. If you see the legend down here. Says that in maybe around 2 to 5 years, we will reach a plateau of productivity. And if I understand the word plateau correctly, as it like.
Gigantic.
Yeah. Based on where it is recently, the white dot is less than 2 years. Based on our progression, we should be reaching in less than 2 years a big plateau of productivity. At least that's what I understand.
Mhm. The funny thing about this chart, which is corrected version of the previous one, in this one, thank you very much, William. You see deep learning is in the lower part, means that, guys, if somebody asks you that, hey, are we going to have at least pretty soon anything like winter of AI, the way that we had for 2 previous winter in AI? You can just simply get to conclusion. We just started with deep learning. And the structure, I'm gonna show you by the end of tonight or today, we're gonna just see the pages that talks about a new version of assigning weights and biases, transformative AI. But the real thing is the structure will stay intact. I look at deep learning like something with programming that we have. Are we gonna say one day you're not gonna use loops, conditions in programming? We are gonna use them in just modern form of languages. Getting to this part, transformative. It mentioned what happened to AI, and we should be very careful. We can't live without internet, but people invested a lot in late 1990s and early 2000. People started, just feeling they lost their interest in investing. It could happen in AI, but at the end, we are going to get back to use AI in everywhere, no doubt. So there's one thing. Deep learning is just one of the algorithms. The funny thing that it mentioned in this paragraph is we don't have only deep learning. If you are a kind of deep learning hammer, and that's the only tools that you have, you're gonna look all the data set as the nail that you want to use just deep learning for it, which is not correct. You have 2 types of data sets. One of them is perceptual like images, voice, data which is not nicely, neatly fit in one data set, like Excel files. For those kind of things, yes, deep learning is the best. For image recognition, voice recognition, and so on, when the data set is bulky, not nicely designed, then deep learning is the best. But for the others, you need to still work on machine learning algorithms. Here it says probabilistic models. Anybody has any opinion what is probabilistic model? We can watch, still we have time. Okay, what are the deterministic models that we have? In contrast to probabilistic models, we have deterministic models. What are the samples for deterministic models? Very simple. If you just add two numbers, for example, 5 plus 2. You're not going to say 5 plus 2 is 7 or 7 point something, right? That's one thing. The other example that we have, guys, please tell me, the stock market, is it going to be probabilistic or deterministic? Why? Because, for instance, you can say that the oil barrel price tomorrow. Can you exactly tell me what the price would be? If anyone can just predict 1 hour from now, they're going to be the richest person, no doubt. You know what I'm saying? If you know what is going to happen just 1 hour from now, you're going to be the richest person. So those are the things that either we are not sure about the parameters that we engage, or we don't know how many parameters we have to engage. They are probabilistic models. In contrast to, so please. Okay, the example, y equal to 5x. I'm going to just fast forward to get to the term. Let's just start. Yeah, here it is. We always have something like this. Y is equal to 5x plus random error or just error. And people show something like epsilon as the sign for the, so 5x plus epsilon. This is the probabilistic models that we could face. So let's go to this part. one of the to go. It goes way back of computer programming. The naive Bayes algorithms. And one of the famous one is logistic regression. Guys, logistic regression is one of the regression algorithms. True, false? It's very obvious. Logistic regression, is it a regression? Yes. Opposite of the name, it's not regression, it is classification. Okay, just to let you know. And for that reason, we are going to watch, I think, either last or second last video. Oh, it's support vector machine, but logistic regression. Second last.
National Bank's online brokerage at $0 commission. Reaction has been swift, Carl.
Yeah.
Hey guys, and welcome to yet another fun and easy machine learning tutorial on logistic regression. To explain the concept of logistic regression, let's imagine that we want to classify whether a Pokemon will win a battle against another Pokemon. How would we classify this? Well, we could look at a set of features such as hit points, size of the Pokemon, attack rating, and defense rating. Now, intuitively, if your Pokemon has insanely high hit points, it will take ages for the opponent Pokemon to destroy yours, assuming the rest of the features are the same in both Pokemon. The same goes for size, attack, and defense Pokemon. So we can represent this using the equation below, where X is your features, we also denote it as theta are your coefficients. Now, if we just take two features such as hit points versus size of a Pokemon, we can use an algorithm such as linear regression and threshold the output. But what if we had an anomaly where the size of Pokemon wins, even though it has low hit points and is small in size? This would lead to misclassification. Also, another problem with linear regression is that it also gives values larger than 1 and less than 0. And this is where logistic regression comes in. Looking at the background of logistic regression. So logistic regression is another technique borrowed by machine learning from the field of statistics. It is a go-to method for classification problems, despite the name logistic regression. It's not another algorithm for regression. Logistic regression is quite similar to linear regression in the sense that they both have the same goal of estimating the values of parameters coefficients. So at the end of the training of the machine learning model, we got the function that best describes the relationship between the known input and the output values. Unlike linear regression, the prediction of the output is transformed using a non-linear function called the logistic function. Some variations of this name are called sigmoid function as well as the logit function. The logistic function, also called the sigmoid function, was developed by a statistician to describe the properties of the population growth in an ecology rising quickly and maxing out at the carrying capacity of the environment. This is an S-shaped curve that can take any real value number and map.
It's one of the, for instance, imagine that we have a test and the cutoff for passing the test is 50. We use logistic regression and the threshold would be exactly like sigmoid function. It's going to show you if it is more than 50, then pass, go to that category, right? If it is less than that, go to the fail category. So look at exactly this one. Because of this, they call it logistic regression. We have that flavor of regression here, but it's going to classify it into two categories, pass and fail.
To a value between 0 and 1, but never exactly at its limits, also known as asymptotes. Looking at the logistic regression equations, so the logistic regression hypothesis is defined as h theta of x, which is a function of g theta transpose x.
The rest is mostly math, so I'm going to just continue. After this, okay. after this logistic regression, one of the early neural networks, you remember we introduced that in this page. This is CNL, or convolutional neural nets, but this one, artificial neural net, you see the feed forward and you see the back propagation. So the idea was not that much recent. But how many hidden layers do we have here? Just one, right? The number of hidden layers here is just one. If you have one or two, we call it what? What do we call the model? Tell me. Is it deep learning? Yes, it is shallow learning. And this guy was there from since 1950s. If you see here, it mentions here. The core idea of neural networks were investigated in toy forms as early as the 1950s. But the thing is, thanks to some of the models, including kernel models like SVM, support vector machine, then they started, the basic form of neural net was forgotten for quite a while. And after that, they came to market again. But can you please check what are kernel models? If I tell you, it's going to be easy come, easy go. So let's just research it by ourselves, and then I'm going to just tell. Number James. And, 1 month. You can ask ChatGPT. You see that, I wasn't joking. What can I do for you? What is the goal for next generation of ChatGPT? You never know, I give it to you. So because it goes with engines and this. It's sorry that it's gonna be. It's gonna be like this. It's the generation. So the number, sir. H is the main object of. Why no? And right? 40. 60. Under how long is it? One small, so don't have to go. Another. Yes, so everything was correct for the improvements. Are you gonna see? You good? You already do all the. Okay. You should say it first. Not yet, but we have things, but I'm gonna say. Just for me to say, So. Say. Sure. See shader today. I guess. Shader. What's the number? Sorry? There's no number? It is. You can just add use of the. Don't worry, I have you over here, but there's a kind of self-enrolled student class. There's no code needed. Just say enroll. Refresh, okay, refresh, apparently the app should be updated, so please update the app. That happens.
Registration for.
I don't, I have to design that registration code. There is no registration. Okay, just update your app. Yeah. Your.
For people.
Okay.
The success of neural networks has sparked the AI revolution in the last 10 years. And from Atari games to Go to Dota and to StarCraft. What many people don't know, the basic idea of neural networks has been around since the late 1950s. Welcome to the origins of neural networks.
We have watched this one, right? Yeah, Jason?
In 1957, Rosenblatt invented the perceptrons, a type of neural network where binary neural units are connected via adjustable weights. He was inspired by the work of neuroscience in the 1940s, which led him to create a crude replication of the neurons in the brain. He tried many different layouts and learning algorithms. Computers at the time would have been too slow to run a perceptron, so Rosenblatt built a special purpose machine with adjustable resistors controlled by little motors. This really is a physical machine. When the neural networks learn, hundreds of little motors went on and turned little knobs to make adjustments. The apparatus was able to classify different images of shapes or letters. The New York Times reported the following on the perceptron.
Maybe revealed the embryo of electronic computer that it expects will be able to walk, talk, speak, write, reproduce itself, and be conscious of its existence.
In the 1950s and 60s, scientists built a few working perceptrons as these artificial brains were called. Using it to explore the mysterious problem of how the brain learns. This perceptron is being trained to recognize the difference between males and females. It is something that all of us can do easily, but few of us can explain how. To get a computer to do this would involve working out many complex rules about faces and writing a computer program. But this perceptron was simply given lots and lots of examples, including some with unusual hairstyles.
But when it comes to a people, the computer looks at facial features and hair outline and takes longer to learn what was told by Dr. Taylor. Andrew Crooks and his team also called it little heart searching.
After training on lots of examples, It's given new faces it has never seen and is able to successfully distinguish male from female. It has learned.
Okay, that one is for the early AI, artificial neural networks. And then we get to kernel models, and I already talked to you about the kernel models. The idea behind these kind of algorithms, especially SVM, is finding the biggest margin, the largest margin. Find a kind of plane, hyperplane, to distinguish, for instance, for this example, black spots from the white spots. But the question is why it is going to pick the largest margin, why we are searching for the largest margin. Guys, it's not a trick question, very simple, but can you step in and say something about it? Why we are searching for the biggest, for the largest margin between, so these lines could be closer to black spots and they work, or they could be very close to white spots and they still work. Any idea? So my suggestion is just search for what is the science behind SVM, support vector machine. What is SVM? Okay, can I have your attention, guys? Because of time, I need to say it myself. The idea of this kernel algorithms, especially SVM, is not finding the coordination of spots, but finding the distance between two classes like this white and this black. The problem of SVM algorithms is, what if we have one spot on the right side, we have several spots as opponents of this? You know what I'm saying? This is the problem. Which one are you gonna consider? The average of it, the center of it, or what? That's one problem. The other problem is when the number of samples grow, it's gonna be exponential, which is not good, especially for large data sets. So exponential data sets is, we try to maximize the margin, because if you bring the margin very much close to whites, what if a white is a little bit towards the black one? So you're gonna misclassify the spots. So as I mentioned, you don't have to explicitly compute the coordinate of your points, but you just need to compute the distances between pair of points. that's one of the issues, how you can find those, and you use a kernel trick by having, okay, let's just see if I mention it. Is something, and if you see it, picture it, it's going to be something different. So look at this one, SVM. We're going to just watch the first few seconds of it.
Building enduring customer relationships. You have to grow with that. Hey, cheese. So the other day I was walking through the park, where I saw a lot of people with their pets, dogs as well as cats. And then I came across this strange creature. It's really challenging for me to tell whether it was a dog or cat. But I eventually figured out that it was a cat. Dog. Now, if it was challenging for me to figure it out, imagine how difficult and challenging it would be for a computer to precisely classify between a dog and a cat. A really great algorithm for these types of applications is the support vector machine algorithm, or SVM. It looks at the extremes of the dataset and draws a decision boundary, also known as a hyperplane, near the extreme points in the dataset. So essentially, the support vector machine algorithm is a frontier which best segregates the two classes. So how does it work? To understand SVMs a bit better, let's first take a look at why they're called support vector machines. So say we've got some sample data over here of features that classify whether an observed picture is a dog or cat. So we can, for example, look at the snout length or the ear geometry. If we assume that dogs generally have longer snouts and cats have much more pointier ear shapes. So how would we decide where to draw our decision boundary? Well, we can draw it over here, or like this. Any of these would be fine. But what would be the best? If we don't have the optimal decision boundary, we could incorrectly classify a dog with a cat. So if we draw an arbitrary separation line and use intuition to draw it somewhere between this data point for the dog class and this point for the cat class. These points are also known as support vectors, which are defined as data points that the margin pushes up against, or points that are close to the opposing class. So the algorithm basically implies that only support vectors are important, whereas training examples are ignorable. An example of this is so that if we have, in our case, of a dog that looks like cat, or a cat that is grown like a dog, we want our classifier to look at the extremes and set our margins based on these support vectors. So we have T plus, which is the shortest distance to the closest positive point, and T minus, which is the shortest distance to the closest negative point. And then we have the margin of a separating hyperplane, which is T positive plus T negative. The line or decision boundary that segregates the two classes is commonly referred to as a hyperplane, because SVMs can be used in multi-dimensional datasets, and the data points are referred to as vectors, as they have coordinates within the space of data. So what we discussed so far is also known as linear support vector machines, or LSVM, because the classes are linearly separable. But what happens if we have a dataset that is not linearly separable? So say we are presented with data that looks like this, where it looks almost impossible to use a single line to separate the two classes. We can use a function to transform our data into high dimensional space. So you can see over here, we go from one dimension.
So the whole idea, higher dimensions, the original data set was like that. You just use one function to increase the dimension, and now with just one simple line, you can segregate, you can just distinguish between these two. Look at the other example. Imagine that. Unfortunately, I can't. Oh, that's it. It's a hard, you see, this one is not easy. So for just taking care of that, what if you just make it three-dimensional? And then simply you can have one plane and just segregate those, separate those groups. By saying that, we get to the parts that, guys, this is something that very much started using, people started using it very much in 2000, all the way to 2010. It was like a kind of to-go algorithm for all the machine learning problems. But the thing is, At the beginning, it was decision tree. Later, they started working on random forest. Why? Because the data sets were huge. And if you want to apply normal decision trees, it takes forever. So they said, let's just have a branches of the data, and they called it random forest, focusing on the strength of the data set that we have, the results that we have. After a while, in 2014, they worked on the other algorithm. It was gradient boosting descent, and it worked on the weakness, tries to improve the weakness of the subsidiary of the original data set of the results. And that was, in most cases, the best algorithm. So for structured data, gradient boosting would be the best. For perceptual, like pictures, sounds, whatever, the best would be deep learning. And yeah, it mentioned this. I'm sorry, let's just go to. It said that gradient boosting, a way to improve any machine learning model by iteratively training new models that specialize in addressing the weak points of the previous model. But it's maybe one of the best, if not the best, algorithm for dealing with non-perceptual. Best neural network. It started saying that Jeffrey Hinton from Toronto. I'm not very much sure, Yeshua, whatever. From University of Montreal. Two of them are from Canada. The other one is from New York University, and a person from Switzerland. So they started working separately. They didn't collaborate. Again, on the idea of neural nets. The team that Dr. Jeffrey Hinton sent to a competition. It was a kind of famous competition. The initial result, working on over 1.4 million pictures, was 74, something 74, 74.3. And the time that he started applying deep learning, it jumped into 9% higher, 83.6. And after a while, they reached to 96.4 that you see. They said that the problem is solved. They don't need to work on this problem anymore. Because the complete name is convolutional neural nets, for sure they say CNN or ConvNet. We are gonna see ConvNet many times in chapter 3, 4. And NLP is one of the subsidiaries that we use. But what makes deep learning different? One of the things that we need to take care of in normal machine learning algorithm is we have to do feature engineering. Question for you, do we need to do that for deep learning? Yes or no? Question again. For other algorithms, you need to do feature engineering. For instance, for support vector machine, if you don't do that, it's gonna take forever to say if it belongs to the cat or dog category. How about machine learning? How about deep learning? Do we need to do feature engineering? Any idea? Bulat, what is your opinion? Do we need to do feature engineering? What is feature engineering? It means that imagine that we have 500 columns. Are we going to use all of them? All the data that we have, are they all important? They're not all important, or at least they're not equally important. So feature engineering is all about reducing. One of the things that we can do in feature engineering, another keyword for interviews, it's dimensional reduction. Means, for instance, you have 500, but among those 500, just 20 of them are super important. You're going to just keep that for machine learning. Yes. Log, no. Log, correct one. They automatically do. But now the second question, the follow-up question, let me just consider that. The follow-up question is, so it automatically takes care of it. Is it better to do feature engineering if we can, or just, hey, forget it, just rely on deep learning? To the interest of time, I need to answer that myself. Guys, it is not compulsory to do feature engineering. It is possible, and if you can do, please do it. Because it takes less time and the efficiency, the performance will be higher. Does that make sense? Okay, feature engineering. It completely automates what used to be the most crucial step in machine learning workflow, which was feature engineering. And now we know what is feature engineering, right? To select or to deal with. Okay, I told you before, there are two things that we have. Do you remember the distillation process and the picture that I found for you before? It is layered step-by-step progress. Incremental layer by layer progress that we have, right? And the conclusion of machine learning and deep learning could be summarized in this. Gradient boosting machines and deep learnings are the most winners among the competition that we had in Canada. But for deep learning, for perceptual again, and gradient boosting for structured data sets. And it says gradient boosting machines for shallow learning problems and deep learning for perceptual problems. Why deep learning? Why now? The idea of deep learning, you saw that black and white video clip, right? It was there for over something like 70 years. But why now we see the result of that in our daily life? Because of progress in three things. Do you remember page number 5? It was, I wrote these three things in the lower portion of the page. Because of the hardware, data sets and benchmarks and algorithms and advancement in algorithms. Remember one thing, hardware. In just 10 years, 1990s to 2010, we had 5,000 times faster CPUs. Look at this one, 5,000 times. It's not like 5%, 50%, or 500 times. That is crazy. The other thing is, we have, thanks to people, thanks to gamers, we had a huge jump in machine learning, deep learning processes because of GPU. It could handle the processes in parallel. But when the miners destroyed the market, we had a problem increasing the price of the GPUs. Anyway, TensorFlow belongs to who? To Google. Google started investing in something, it's like, 5 years now. That they call it Tensor Processing Unit, TPU. Recently, I haven't checked it, but 2-3 years ago, it was not that much great. GPU was way better. The other thing is data. It said the amount of data that we have today and we can process is amazing. And the reason for that is we have cloud, internet, and all those services that we have over the internet. Before that, we couldn't imagine. And the internet make it feasible to collect and distribute every large data sets for machine learning. Look at this one, ImageNet data set. It had 1.4 million images. Can you imagine how much you need to put effort to create something like that yourself? Do you remember that? I told you before, there is one Russian scientist one day he woke up and said, instead of using sigmoid, let's just use ReLU. Remember that? So the advancement that we had in algorithms make it possible for us to reach where we are. We didn't have backpropagation the way that we have it today since 2014. So Jeffrey Hinton worked and the team worked on that backpropagation. And the other thing, so you see that it says better activation functions, sigmoid ReLU, better weight initialization. Right now, I said, guys, random, but you're going to see in a second that it's not very much random. Recent algorithms, they start not from just random. And the last one is optimizers. So Adam was the dominant one 6-5 years ago. Now mostly we use Rams prop. In short, the algorithms that we have, we didn't have it 20-30 years ago. Lots of investment. It said, hey, we are gonna longer story short, we are gonna see more of deep learning. Piano and TensorFlow are two libraries. We have another one, Microsoft MSTK. They are all under the umbrella of Keras. Keras is something like an overlay library. It's not library like TensorFlow. One hint, if you work with Keras and you see that it doesn't work, replace it in most of the cases with TensorFlow, and it is compatible with the version that you're dealing with. It happened to me a lot. So sometimes they upgrade and they forget to make it compatible with the other parts of the Python. So one of the things that you can use is using TensorFlow instead of Keras. But most of the time, what we do in Keras is equal to what we can do in TensorFlow. Why we use deep learning? Deep learning has several properties that justify its status as an AI revolution. It really deserves the words revolution instead of evolution. And these important properties can be broadly sorted into three categories. One of them is simplicity. The other one is scalability. Thanks to the architecture that we can use, GPUs, we can run thousands of processes at the same time. So it says that GPUs and TPUs. And the other one is versatility and reusability. You can just, for instance, if you trained your model based on 100 animals, you can reuse that model, saving hours of retraining the model, because you do not start with random weights and biases. You have something in your model, you're gonna work on it to tune it. And if you look at this one, this is pretty recent compared to deep learning, and that is transfer learning. In transfer learning, you have an idea of what the other models, similar to the case that you want to work with, have in their weights and biases. So you're not going to start from the scratch. That's the gist of one of my classmates who defended her thesis a few years ago. She worked with this algorithm, transfer learning. By saying that, next week, we are going to start working on hello world in deep learning, which is working with MSTN. And MSTN is the data set which was provided by American Post Office in 1980s. They started working on it using traditional programming, and it's a kind of rich data set that we use to train our models. I'm telling you, it's a hello world for deep learning. Hands-on is going to start next week. Thank you very much. Now it is 2:50. If you have any question or concern, I'm going to stay. Otherwise, see you on the lecture next week.